Okay, so we have this problem, and it says that we have the heights of college women normally distributed. The heights have a mean of 65. Okay, I have my wrong marker. And a standard deviation of 2.5. Now, every time I give you a problem like this, I want you to draw the normal distribution because it's really important that you can see visually what's happening. So this means that we have an average of 65. We go up 3 standard deviations, down 3 standard deviations. So when I go up, I add 2.5 each time. So I have 67.5, and then I have 70, and then 72.5. This way, what do I have? 62.5, and then 60, and then 57.5. So there's my entire normal distribution based on this data with an average of 65 and a standard deviation of 2.5. So the first question says, what percentage of women have a height between 62.5 inches and 67.5 inches? So you're going to go to your distribution. 62.5 is here. 67.5 is here. You're going up 1 standard deviation and down 1 standard deviation. What percentage of data falls within 1 standard deviation? 68%. Okay. Any questions on that one? Okay, part B asks you what percentage of women fall within 60 to 70 inches of height. And you notice it's 95 because we're up 2 standard deviations and down 2 standard deviations. So between 60 and 70, we have 95% of the women. Okay? Any questions? So the second problem, this is the great thing about using a whiteboard, I just have to erase this, says that according to the College Board, the mean score for the verbal SAT is 502, so that's my mean score, and I have a standard deviation of 109. Okay? So again, I'm going to go to my normal distribution, put the mean in the middle, and then keep adding 109. Help me with this. So this would be, what? 611, 720, and 829. And this way? 393, 284, and what?
175.
Thank you, 175. Okay? So, I want to know what percentage of students scored between 393 and 502. So I go to the distribution, and between 393 and 502, I'm 1 standard deviation below. Not 1 standard deviation within, just 1. I know that if I went plus or minus 1 standard deviation, I'd have 68%. But because the distribution is symmetric, I can cut that in half. And what percentage do I have here? 34%. And that is the solution to that one. Okay? Any questions? Now the next one is a little bit more difficult, and there are 2 different ways we could do this problem. The question says, what percentage of students scored higher than 720? Okay? Now, we know that below the mean is what percent fall below the mean? 50%. We know that within 2 standard deviations, well, let's go 1. Within 1 standard deviation, what percentage is there? 34. And we know that if I go 1 more standard deviation, what percentage of data is there? 13.5. If I were to add 50, 34, and 13 and a half, I'd get what? 97.5. Okay? Is that correct? Okay? So if this from here down represents 97.5%, what percentage of data represents this section? 2.5%. And how did you get that? 100 minus 97.5. Now, there's an easier way to do it. Anybody do it the easier way?
Yeah. I just sum up 2.35 plus 0.15.
That's right. So we also know that this section here represents what percentage? 2. And we know that this little section represents what?
1.5.
And when I add those two, what do I get? 2.5%. So there are different ways to do the same problem, okay? Some of them a little bit easier than others, but you still come to the same conclusion. Questions on that?
I did it differently.
Okay, hold on. Let me erase this because I want to write that down. Let me do this again because it looks a mess. All right, so this was 502. Then what did we have? 611, 720, and 8 what? 29. That's right, it's 109. Okay, so go ahead, Jessica. How'd you do it?
So between the 284 and the 720,
284 and 720.
I knew that was going to be 95%.
95%.
And then I just did 100 because the whole thing was 100
Yep.
minus 95.
And you got 5%.
And then divide by 2.
And then you divided that by 2 to get the 2.5% on either side. And then 2.5 over here. Yep. So there are 3 different ways to do the same problem. It's a good way to check your answer too. Okay. All right, and the last part of that one said if 700 students took the exam, how many scored between 393 and 611? So 393 and 611 is what? What percentage did we say fell there? 68%, okay? I know that 68% of my students, or of the students taking the SAT, are going to fall between 393 and 611. If 700 of the students took the exam, to figure out how many would score within that middle, I multiply 700 by 68%. But you have to remember, you can't multiply by 68, you have to multiply by what? You have to change that percentage to a decimal, 0.68. So how many students did you get? 476. Okay? Yes?
I just multiplied 68 7 times.
You
My
multiply.
7.
You
Because I know
multiplied.
700 is
Oh, okay, yep.
larger than 100. So.
Yeah, that works. So, because 700 is, we know that when we have 68 as a percentage, it's 68%. You're actually dividing by 100, so you can do it that way. All right. So now let's look at the very last problem. You guys getting good at drawing normal curves? Okay, so the last problem says, on a certain exam in statistics, there was an average grade of 75 with a standard deviation of 8. Okay? So again, before you even look at what the problem's asking, once you know it's normally distributed, and I give you the average and the standard deviation, you want to draw that curve and write that down. So we have a 75. We're going to go up 3 standard deviations, down 3 standard deviations. I'll add 8. I get 83. I'll add 8 again, 91. I'll add 8 again, 99. I'll subtract 8, 67. I'll subtract 8, 59. Subtract 8 again, 51. Okay, now based on the data, that's what my distribution looks like. So I want to know what percentage of grades were between 59 and 91. This is why you draw it, because you can see visually that you went down 2 standard deviations, you went up 2 standard deviations. You know what percent of data falls within 2 standard deviations? 95%. Okay? Questions? How about between 83 and 91? What percentage did we find in that standard deviation there? 13 and a half. So between 83 and 91, we get 13.5%. And if 50 students took the exam, how many would have scored between 67 and 83? And how did you get that? Well,
I cut 60 in half. Because half, 50 is half of 100, so I just divided by 60, and I have 60 by 2.
for 67 to 83?
Yeah, because I know that's 68% of the data.
Right.
I know 50 is half 100. So.
Oh, I see how you did it, yeah. So that we know that that's 68%. So we know that if 50 students took it, we multiply 50 times 68% to get what?